Okay, let's see what they have for today. Alright. Well, hello there. Today we're gonna talk about something kinda cool. Components and actions. And maybe some component actions in the middle. If you're wondering why I'm covering all three of these topics in one video, well, I want this video to be a bit longer than 4 minutes, which is about exactly how long it ended up being at first. Okay, enough babbling, let's talk about them components. What is a component? A component is a set of variables and methods that are meant to manage a single property of the entity the component is added to. Stuff like edible for foods, health for mob entities, or bird spawner for the world. Adding a component to an entity is as easy as writing inst::add component, with inst being the entity. For the curious, this is how odd component looks like. Components that are added to entities are saved in the components table, so you can access them by indexing it, like this. Two interesting functions are run here, replicate component and register component actions. I've mentioned replicas in my previous video, and I'll mention them a bit in this video as well, but component action is a new one. Basically, do you see this eat prompt when hovering over your gourmet 5-star meal? That's thanks to the player action picker and component actions. Whenever you add a component, in this case that would be edible, the game checks whether there exists a component action with the same name. Currently, you can have 5 types of component actions: seen, use item, point, equipped, and inventory. Edible is in 2 of these types: use item and inventory. These functions are then put into action replica for the client to use later. Now, whenever you hover over an edible item in your inventory, or you try using the item on other entities, one of these functions will run and insert an appropriate action to the actions table. This actions table is used inside player action picker, where it's sorted based on action priority, and if everything goes as planned, you should be able to right-click the food and the player will perform the eat action. Now, if that sounds complicated, it's because it is. Let's quickly go over the eat action to better understand actions in general. All of them can be found in actions.lua, which is surprisingly where the action class is also declared. You might be thinking, wow, that's a lot of parameters, and you'd be incorrect because you're not actually supposed to use these, as they are all deprecated. All the additional data should be stored in a table as the second parameter. Luckily for you, the eat action has only one additional data variable called mountValid, which, as you could probably figure out, allows us to perform the action while riding a beefalo. How does the game know what this action is supposed to do? Approximately 314 lines below this first declaration, there is a function written called fn, and this is exactly how it knows. Here's the code that runs when the action is performed, and it's here you will see the most condition checks. If this function returns true, the action will succeed. If it returns false or doesn't return anything at all, the action fails, and the player states that they can do that. Performing the action, as in playing the appropriate animation and finishing the animation, quote-unquote, is managed by the state graph, which I will not be talking about in this video. However, I will tell you how to set up a quick and short and not very long action handler for the custom action we'll create today. Alright, enough exposition, let's write some code. As we already have a custom item in the game in the form of a plushie, I think it's only appropriate that we create a component that lets us hug it. Go ahead and create a folder inside scripts and name it components. Inside, we'll create a Lua file and call it huggable. Every component file needs to return a class, so let's create a local huggable class and write a base constructor function. As is with every component, we're gonna save the instance of our entity as self.inst. At the bottom, we'll return this class. From now on, what we'll write in here fully depends on what kind of component we want. I think we should be able to restore some sanity when actually hugging the plushie. For that, let's create a variable for how much sanity we want to restore. Let's set the base value to 0 for now. Additionally, I'm gonna write a setter and a getter for this value. There are a few ways you can write a method for a class. You can do it inside the constructor or outside of it, using a dot or a colon. I'm gonna write it like this. This method will be the getter, and this one will be the setter. One will get the value and the other will set it. Insightful, I know. Have you ever wondered why this self variable can be used in methods despite not being declared anywhere? Well, in Lua and most other object-oriented programming languages, a method's first parameter will always be the object itself. The name of this hidden parameter varies from language to language. In C++, for example, we use this. Lua, however, calls it self. This self parameter makes a big difference when calling a method using a dot instead of a colon. This will fall under base Lua knowledge, which I don't usually aim to talk about since I want to focus only on modding, and you should know at least the basics, but for this one I'll make an exception. In Lua, a function is the same thing as a table or a number. It's just a type of variable. Writing something like this is virtually the same as creating a variable that holds a function type value. Let's create a small table with one function variable. How do we call this function? There's two ways we can do that actually. The most obvious way is to simply access the variable by indexing it, the same way you would access any other table value and then call it using parentheses. However, if you know at least a little bit about coding, you might know we can also use a colon to run a function. Now look what happens when we switch the dot for a colon. That doesn't look like the string we passed as the parameter. Why is that? You know now that calling a method of a class using a colon sets the first parameter as a self. This is exactly what's happening here. But isn't this a table and not a class? Well, yes, but just take a look. An object of a class is just a big table with some fancy metatable stuff thrown on top of it. This distinction will save you a lot of trouble with parameters in your modding adventures, trust me. Alright, tangents over. I've already forgotten what we were talking about. Oh right, so we have our sanity gain variable. Cool. Now let's add this component to our plush and let's call our setter. I'm gonna set it to, let's say 15. I think it's time to write a component action for our component. To create a component action, we're gonna use add component action. Oh, that was a lot of component actions. A global function that's also a part of the mod's environment. The first parameter is the type of action we want to create. We want to be able to use the item from our inventory, so we'll write inventory in all caps. The second parameter is the name of the component that's supposed to allow us to perform the action. Here, write huggable. The last one is a function, very similar to the edible one I showed you earlier, although ours will be way shorter. We're gonna check if our active item is empty and if a player is not riding a beefalo. Active item, for those that don't know, is when you click an item in your inventory and have it on your cursor. You might be wondering, wait, why are we using replicas in here instead of components? Now that is because the server doesn't need to know what actions are currently available for the player. Component actions are checked only on the client, and so you don't have access to most of the components. Replicas, however, are a different story. Remember the replicate component I showed you in the add component function earlier? This is what adds the replica to our entity. Only a few components are replicable, and if you were to create a replica of your own, you would need to add it to the stable first, which is easily done with add replicable component, but we're getting off topic here. In short, you add a component to an entity, the game checks whether there exists a replica on the component, and it adds it to the entity. Boom, you can now use replicas on the client, unlike components, which cannot be accessed on the client. If these checks pass, we can insert our hug action, the one that we haven't created yet, of course. Let's do that now. Above the component action, write add action. The first parameter will be the ID, or the name, so hug capitalized. The second one is the string that's supposed to show up when our action shows up. This one will be hug with an exclamation mark. The third one is the function that will be called when the action is performed. Let's check if our item exists, just in case. And then let's run the hug method and return true. Return false otherwise. We haven't created this hug method yet, so let's do that now. It's gonna be a part of the huggable component, and it's gonna have a parameter doer, our player. Check if doer exists, and whether they have a sanity component. If so, run sanity components do delta, and increase it by our sanity gain value. And now it's time to specify a state for the player to go to when performing our action. For that, we have add state graph action handler. We need to specify what state graph we're editing and write what action handler we want to add. Both the action handler and the actions table are not in the mod's environment, so we need to index the global table to access them. The second parameter for the action handler is the state name, which I will set to do long action for now. This is a pretty generic state, used for stuff like crafting or picking grass or twigs. Now you can open the game and watch as your character doesn't play the correct animation. Although you can hear the sounds, and you do get the sanity boost as expected, so what's wrong? Networking, unfortunately. Player state graph is broken up into two state graphs, one simply called sgwilson, and the other one called sgwilson_client. We've only added an action handler for the server-side state graph, and in order for our action to be displayed properly, we also need to add one for the client state graph. Simply copy this line of code and change sgwilson to sgwilson_client. Man, coding really is just like homework. Hey, you were supposed to make the player play the hugging animation. That's not that. Well, shit. I'm gonna leave state graphs for the next video. And maybe I'll throw a custom animation tutorial as an extra. We'll see. I'm bored. I'm gonna go play some Left 4 Dead. See ya!